Hello students, today we are going to start the chapter Constructors. So, in the previous lecture, we created a program to demonstrate you a simple class. And in that program, there was a class, suppose its name is simple class, and inside the class, we had some private data members. Suppose they were A, B. Okay. And in the public section, we had two member functions. One was void set data, and its function was to initialize the values of A and B. So A equal to X and B equal to Y. Okay. So this was the function set data. There was another function display data or show data. Okay. So that is not our concern at this point. Let us focus on this function set data. Okay. So the purpose of set data here is to initialize the values A and B, to initialize the private data members of this simple class. Okay. So inside the main function, what we can do? We can create an object of simple class. Suppose its name is obj. Then in order to initialize the values, we called obj dot set data and we passed some values. Okay. So this was the function of set data. Okay. So the question here is that instead of using this specific function set data, can we create something which can automatically initialize the data members of a class when the object is created? So what we want is, we want that when we are creating the object of this simple class, we do not want to explicitly call set data. We want that we can initialize these values as we are creating the object at the same moment when we are creating the object. And this is possible in C++. This is possible using the concept of constructors. So why are constructors necessary? Let us take an example of a car. So you created a class car. So car contains various functions, such as one of them is, suppose, shift gear. So using this shift gear, we can change the gear. So when we create the object of this car, suppose car obj, then if we do not initialize this gear, this is the private data member. Okay, so gear is the private data member of class car, and shift gear is the function which operates on this variable gear. Okay, and we create an object of class car, but we do not initialize gear object. Then what will happen? The gear will automatically be initialized to some garbage value. So this variable will be created in the memory when you will create class car object, but it will contain some garbage value. Okay, and then using the object you call shift gear. Then what will happen? The shift gear will operate on the garbage value which is there in gear. So it will make gear plus plus, and if there is some garbage value, suppose this, then it will be incremented. But you do not want this. You want the initial gear value to be 0, that is neutral. Okay, so in this example, you want that every time you create a car object, the gear is always initialized to 0. Okay, so even if the programmer forgets to initialize gear object, you want that it should automatically be initialized to 0. Then what we can do in that case? We can create a constructor. The constructor will automatically be called whenever you will create an object of class car, and all the necessary data members will be initialized properly. So this is the purpose of constructors. Okay. So now let's move forward. So as I already told you, it is convenient if an object can initialize itself when it is first created without requiring a separate call to the member function. Okay, so we do not want to explicitly initialize the object data members. We want them to be initialized automatically, as in the car example. Okay, and this automatic initialization is possible using constructor. What is a constructor? Constructor is also a member function of the class, and it is a special member function. Special because it is called automatically. You do not call it using object dot constructor name. You do not write this. It is called automatically. That is why it is special. And what is the purpose of constructor? The purpose of constructor is automatic initialization of the data members of a class. Okay, and it is executed automatically whenever an object is created, right? So this is about the introduction to constructors. Okay, now what is the name of this special function constructor? So while naming the constructor, there were two issues. First is, any name you use is something that can potentially clash with the name you might like to use as a member in the class. For example, you created class car, okay, and it has, suppose, one variable gear, okay, and you want it to be initialized in a constructor. Then if you name the constructor as init gear, okay, and here you are initializing the gear equal to value 0, then it might happen that the same name init gear is used somewhere else also inside this class. So there is a clash. Okay, so for two things you are using the same name, so that is a problem. Then second problem is, because the compiler is responsible for calling the constructor, you are not explicitly calling the constructor. The compiler will automatically call the constructor. The compiler must always know which function to call. Okay, so every time you are not going to tell the compiler that call init gear. Init gear is the constructor here. The constructor must automatically know that which one of the member functions is the constructor. So what was the solution then? The solution Stroustrup chose seems to be the easiest and most logical. So what was his solution? The name of the constructor is same as the name of the class. So if the class name is car, then instead of init gear, the name of the constructor will also be car. What will happen with this? One thing is that this name is a special name because this is also the name of the class. So it will not clash with any other name inside this class. And second thing is, because it has the same name as a class, the compiler will automatically know that the function which has the same name as the class is the constructor. So the compiler will find the constructor and call the constructor automatically. Okay, so now we move on to an example how to create a constructor. So here we have a class X, and inside this class we have a private data member I whose data type is integer, and inside the public section we have written X and then parenthesis and then semicolon. Now the name of the class is X and name of this function is also X. It means this is a constructor. Okay. And this constructor has no parameters inside this parenthesis. So this is an empty constructor. And when you create an object inside this void f, what is void f? Void f is a function, and inside this function what are we doing? We are writing xa. So xa means we are creating an object A of class X. Then what will happen? When you are creating an object of a class, the constructor will be called automatically. Okay, so the same thing happens as if A were an integer. So if you write int A, then what happens? Memory is allocated to variable A. Similarly, when you write xa, what happens? Memory is allocated to variable A, where A is an object of class X. Okay. But when the program reaches the sequence point, that is, what is the sequence point? The point of execution where A is defined. When your program reaches here, it means the constructor is called automatically. So when you are creating the object, when you are executing this line, then this constructor will be called automatically. Okay. So you are not writing A dot X. No, it is being called automatically. You do not need to write it. Okay. So that is, the compiler quietly inserts the call to X scope resolution X. It means, what are we doing here? We are calling the X member function of class X, where X member function is the constructor for object A. Okay, at the point of definition. At the point of definition means where you are defining A. Here you are defining A. Here you are creating A. So here constructor will automatically insert the call to this constructor. Okay. And like any member function, the secret argument to the constructor is this pointer. So what happens whenever you are calling a member function? For example, let us take the previous example of the simple class. Simple class, and it had some private data members and it had some public member functions. That was void set data and void display, suppose. Okay. There were something inside the function bodies. Okay. And when you created an object of simple class obj, then after creating you called set data and you passed some values, suppose 10, 20, right? So actually you are passing two arguments, 10 and 20. This 10 and 20 are the values of the data members A, B of simple class. Okay. But secretly one more argument is passed while you are calling the member function of any class. And that secret argument is this pointer. What is this pointer? This pointer is a special pointer. This pointer means this is the address, because this is a pointer, it means this is an address of what? This is the address of the calling object. This means this object through which we are calling this set data. Okay, so secretly we are also passing the address of this object. And what is the purpose of passing the address of the calling object? Through this, the compiler knows whose data members are we setting. Okay, because there can be multiple objects of simple class. Suppose obj1 can be there, obj2 can be there. Okay, so each of them will have their own data members. A, B. These are A and B of obj1, and here these are A and B of obj2. Okay, and whenever we are calling set data through an object, then we need to tell the compiler that whose obj we are calling, so that it can set the data of, it can modify the data of that object only. Okay, so when you are calling obj1 dot set data, then secretly it is also passing the address of obj1. So address of obj1 is passed. It means the A and B data members which are related to obj1, they will be set to 10 and 20. Okay, and when you are doing obj2 dot set data, then secretly the address of obj2 will be passed. Okay, so it will affect the data members which are the part of obj2. Okay, so these will be set. Okay, and the address of the calling object is contained in a special pointer by the compiler automatically, and that pointer is called this pointer. Okay, so same thing happens when you are calling a constructor, because constructor is also a member function of a class. So by default, the address of the object for which it is being called, it is implicitly passed. Implicitly means it is passed automatically without passing it explicitly. Okay. Let me erase this content. Okay. So in the case of constructor, however, this means the pointer is pointing to uninitialized block of memory. Why? Because whenever you are going to create the object, the constructor is called automatically. So constructor is called automatically, and because the constructor is called, so what we are passing to the constructor? This pointer. Okay, so here what happens when this statement, the execution reaches this point, then automatically a dot x is being called, and where x is the constructor, and address of a is being passed. Okay, but address of a means the address of this object A, but we have not yet created A. Okay, that is why this is pointing to uninitialized block of memory, and it is the job of the constructor to initialize this memory properly. So when we reach here, then constructor automatically initializes the block of memory which belongs to object A. Okay. And one thing to note here is that both constructors and destructor. What is destructor? It is similar to constructor. Constructor is used to initialize the values, and destructor is used to free the memory which is consumed by an object. Okay. So we will discuss destructors in detail in few next slides. Okay. But before that, I want to tell you that both constructor and destructor, they have no return type. Okay, they have no return value. This is distinctly different from a void return type. Normally, when we write member functions which have no return value, we write void. Okay, it's like void set data. Okay, in which the function returns nothing, but still you have the option to make it something else. Okay, so if the function returns nothing, you write void. Otherwise, you can change it. Okay, if you want set data to return some value, you can change it from void to int. If there were a return value, if the constructors had a return value, okay, let me erase it first. if there were a return value and if you could select your own, okay, if the compiler had a return value, suppose we could make it int x instead of just x, then the compiler would somehow have to know what to do with this return value. Because it is called automatically, we do not tell anything about x to the compiler. But if you write some return type, then you have to tell what to do with the return value. Okay, or the client programmer have to explicitly call constructors and destructors. If we cannot tell the compiler what to do with this return value, then the programmer who is writing the program had to explicitly call the constructors and destructors. Why? Because only the programmer can know what to do with the return value. Okay, but this option would eliminate their safety. Safety means they are called automatically. So if you are calling them yourself, then you can make changes which are not desirable. Okay, so this would eliminate the safety. Since the constructor is called automatically by the system, there is no program for it to return anything to. Okay, so it is called automatically. We do not have a function call inside the program to call a constructor. Okay, we do not like write this int x equal to a dot x. We do not write this. This is called automatically. So what can we do with the return value? We cannot do anything. Okay, therefore there is no program for it to return anything to, and return value would not make any sense. Okay, and this is also the second way the compiler knows they are constructors, because all the other normal functions they have a return type, only the constructors do not have a return type. By knowing this, also the compiler detects which is the constructor among all the member functions. Okay, then we have this initializer list. Initializer list means how to initialize the values inside a constructor. Normally, suppose count is the name of the constructor. So count, then parenthesis, inside the curly braces you initialize the values. Okay, suppose there is a data member count and you are initializing it to value 0. Okay, but what is the preferred approach? Preferred approach is to initialize the values outside the function body. So this constructor body is empty here, but instead we are initializing it in the function declarator. Okay, so here we write the name of the constructor, parenthesis, and after a colon we write the value which we want to initialize. Here the value is count, so count is being copied here, and inside the parenthesis you write the value which you want to put inside count. Okay, so if multiple members must be initialized, they are separated by commas. For example, this is some class, the name of the constructor, then colon, and here you are initializing multiple members. M1 equal to 7, M2 equal to 33, and M3 equal to 4. This should be M3. Okay, so this is called the initializer list. This is the initializer list. Okay, this is same as saying that some class, then parenthesis, then M1 equal to 7, M2 equal to 33, and M3 equal to 4. Okay, so both of them are same. Okay.